Welcome to this video in our course Competition Policy and Strategy. This video is on exercise 7.4, so the fourth exercise on the seventh assignment. And in this exercise we are now leaving the world of horizontal mergers and entering the world of vertical mergers with, in this case, more specifically, a vertical merger with competition on the upstream market. Alright, so in this setting, or we are confronted with the following setting. We are looking at the electricity sector in a country, and this electricity sector in this starting situation has two firms. There is one electricity producer, we call it PG, and because it's the producer, it's in the upstream market. And there is one distribution company, let's call it TSO, which, because it's in the distribution company, is active in the downstream market. All right, now let's learn a little bit more about the firms themselves. First, PG, so our upstream producer, is producing at constant marginal costs of C equal 4. The downstream distributor, TSO, does not incur any cost of power distribution, right? So the only costs that TSO incurs is the wholesale price that they are asking the electricity from the upstream producer. There is no additional costs of distribution. So, yeah, I already said it, TSO, so the distributor purchases the electricity from PG, so the producer, at some price W, the wholesale price per unit. The end consumer demand for electricity is defined in this demand function, price as a function of quantity equals 124 minus Q, where Q, of course, is the total amount of electricity produced or demanded, however you want to frame it. All right, now that is our scenario, and in this world we are now first going to analyze a situation where both of these firms are vertically separated. All right, so both PG, so the upstream firm, and TSO, the downstream firm, maximize their profit independently. We are asked to determine the amount of electricity traded in equilibrium and the equilibrium retail price, of course, the wholesale price W, the equilibrium retail price P and the wholesale price W. All right, let's start with this, maybe most simple version of a vertically separated model where there's one upstream firm, one downstream firm. We usually, because this is the first time we are actually talking about vertical competition throughout this whole lecture series, and just as a quick reminder of the contents of the lecture, we solve this kind of market, or we find the equilibrium in this kind of market by first taking a look at the downstream market, and once we have found the profit maximization, or stated the profit maximization problem, and have stated the profit maximization in downstream market, well, then we take the result of this analysis and consider it for the upstream market. Take the result of the profit maximization that is happening downstream as given in our profit maximization that is happening upstream, so to speak. All right. Following this logic, let's have a look at the downstream market, or at the firm TSO. So we have, by assumption in this exercise, we have a profit maximizing monopolist, right? So there is one single firm in this market that is facing the end consumer. The profit function of this firm, pi TSO, then reads 124 minus Q minus W times Q. Where does this profit function come from? Well, generally what we see here, we have the downstream firm's profits is, we have the price minus costs, so to speak. So this is the general version of the profit function, right? We have some version of profit margins times the quantity sold. However, these costs are from when we are talking about the downstream market, these costs are of course not the marginal costs of production. That's simply not how this vertical separated market works. Instead, we described in the exercise text that this downstream firm is purchasing each unit of electricity at the wholesale price W. So from the perspective of the downstream firm, the wholesale price is the costs of each unit. So what we have here is price minus wholesale price multiplied with quantity. Then, of course, all that's left to do is substitute P with the demand function that is given in the exercise, and you result with the profit function that is written on the slide. Now, if you want to find the profit maximum, of course, we need to state the first order condition of the maximum of this profit function, right? And we do this as we usually do. We have a monopolist. We know the profit function of monopolist. How do we find the profit maximum? Well, we start with the first order condition, which of course means calculating the derivative of the profit function with respect to the quantity. So, if we do so, we come to the realization that in this profit function we have not only left the quantity as a parameter determining the maximum, but instead we in addition now have this we have this wholesale price, W wholesale price. So we cannot find the profit maximizing quantity this way simply because we don't know the welfare price yet. What we can do, however, is we can express the welfare price as a function of the quantity sold to the end consumer. And we can do exactly this simply by solving this first order condition for W. So we now have the wholesale price as a function of the quantity that's sold in the market, and this reads in this scenario 125 minus 2Q, right? Simply by rearranging this first order condition. And at this point, we are basically done for now with the downstream market. That's all we can do. We can state the wholesale price as a function of the quantity demanded or sold in the market. So, as promised, after considering the downstream market and trying to solve solving the profit maximization problem in the downstream market, let's then consider the result of this when we are moving up one level in the market towards the upstream market. So that's the next step. Let's now consider the upstream market. And exactly the same to the downstream market, of course, is that we, by assumption, have a monopolist in the upstream market. So what we need to state in order to find the market equilibrium is the profit maximization problem of a monopolist, which, similar to what we just saw, is, well, in general terms, we have some version of the profit equals price minus costs times Q. Now, the crucial thing is when we're looking at the upstream market, that this price right here is not actually the end consumer price. Right? Simply by construction of this model, of the market that we are modeling, this firm is never charging any end consumer price. Instead, what this firm considers as the price at which they are selling their good to the downstream market, of course, is the wholesale price. All right? So, in this profit function of the upstream firm, the wholesale price takes the conceptual position of the price at which the firm is selling. So we are now looking at the upstream profit function, which reads wholesale price minus marginal cost of production, because upstream is the producer, it's actually facing production costs, multiplied, of course, with the quantity that is sold in the market. And you will see that the profit function of the upstream producer, PG, follows this exact structure. We can, of course, and that's what we're doing in this step, we can, of course, substitute W for the function for W that we already know from the downstream market. W does not just take any value, but instead we already found out that in equilibrium W must take this function down here, W wholesale price, as a function of Q equals 124 minus 2Q. So consider this function for W as a function of Q, consider this function in the profit function of the monopolist upstream, and we result with the profit function written right here. Alright, now this profit function of course only depends on quantity, which is exactly what we're used to when looking at more simple models of the monopoly, and of course is something that we can easily solve for. So we now find the profit maximizing quantity by calculating the first order condition for this maximum, which of course means setting the first derivative of the profit function with respect to the quantity equal to 0. And if we do so, we can read that well, 120 minus 4Q must equal 0, so Q must equal 30, right? So we know Q equals 30. If Q equals 30, then we can, let's write this down. If Q equals 30, then we can use this market equilibrium quantity of 30 in order to calculate wholesale price W. Wrong direction, which was right here. So we have 125 minus 2 times 30, so minus 60. So we have 64 as the wholesale price. Ta-da, right there it is. And knowing the quantity sold in the market and the wholesale price in the market, we of course can calculate the price in the market as well, simply by looking, by plugging the quantity into the demand function, right? And now we have found, the market equilibrium, in the sense that we now know the wholesale price in the market, the quantity, and the price in the market. All right, we are now continuing away from this benchmark situation where we had two firms separated, one on each level in the market, one upstream, one downstream, both were monopolist, and so on. Task A was of course some version of a benchmark situation, and now we want to analyze what happens to the market result if these two firms merge. So what happens in a vertical merger, right? Between these two firms that were formerly vertically separated. So we are now going to assume that PG, so the producer upstream, and TSO, so the distributor downstream, merge. And we are asked to determine the equilibrium quantity as well as the equilibrium price in this situation. And then we are finally asked to answer the question, should the merger be allowed? How do we do this? Well, conceptually, this exercise becomes really easy once we realize that conceptually what is now happening is that there's one single monopolist in the market, right? Post-merger, we have one single firm that is producing and selling to the end consumer. So there is no wholesale price, there is no thing in the middle happening, there is just one single monopolist. So what we are now faced with, of course, is the simplest monopolists model that we already know from the very first exercise or assignment in this course. So this monopolist then has this profit function, so there is basically P of the demand function, P minus the marginal costs of 4 multiplied with the quantity. We find the profit maximum of this monopolist, of course, by stating the first order derivative, by stating the first order condition, which means the first order derivative must equal 0. And we find out through this that the equilibrium quantity is 60 and the price is 64. All right. So what we then realize is the quantity actually went up, right? Because in the previous exercise we saw the equilibrium quantity was only 30, the price was 94. Now moving towards the monopoly, which we know from previous exercises is basically the worst possible outcome from a consumer's perspective, we see that prices decrease, quantity increase, which is quite a curious finding. And this, of course, is a hint towards the answer to this question: should the merger be allowed? So, in order to answer this, let's have a look at consumer surplus, let's have a look at firms' profits and assess the whole situation. In the world before the merger, we had two separate firms, and we can calculate, of course, the profits just by taking the result of task A into consideration and calculate the profits downstream and upstream. When we do this, we can see that the total profits in the market, so the sum of profits upstream and downstream, pre-merger are 3,600. No, excuse me. The total profits pre-merger are the sum of 900 and 1,800, so we are looking at 2,700, of course. The profits in the world post-merger are 3,600. Right? So the profits post-merger are decreasing, are increasing. Profits are increasing with the merger, which shouldn't be too surprising. At the same time, we see that the consumer surplus in the world pre-merger was only 450. In the world post-merger, we see 1,800. So let's mark it like this. We see an increase in firms' profits and we see an increase in consumer surplus. So firms and consumers benefit from the merger. And what's the reasoning behind this? How is this even possible? Well, the reason is that in this world where we have previously had two monopolists, we have this phenomenon that is called double marginalization, which means that on each stage of the market, upstream as well as downstream, we have this monopolist that is charging the monopolist's margin above the costs and thereby reducing the quantity in the market, increasing the price in the market. And because this is happening twice, we see the result that we saw in task A. Now in task B, we get rid of this double marginalization, we only have one single monopolist, and what we can see is that actually the profits as well as the consumer surplus increase. All right. So that's it for the comparison between a situation where there is one monopolist up and one downstream with a situation where there is only one single monopolist. So there is basically a vertically integrated firm, right? Let's now provide another perspective, provide another version of the model. In task C, we are now again considering the vertically separated industry structure. So we again have a producer level and a distributor level, upstream and downstream levels in the market. However, in this situation, we do not only have one power producer PG, but there is one additional, a second power producer called PG Sun in the market. Both are producing at the same constant marginal costs, and both are competing in quantity, or competing in a Kono competition. Downstream, nothing changed in the sense that there's still only one monopolistic distributor called TSO. We are now, for this situation, asked to determine the market price, the wholesale price, and the quantities in equilibrium. And then we are asked to assess again how we should, or we're then asked to assess whether the merger between PG and TSO would be approved or should be approved in this setting where PG has a competitor. Okay? Right, let's do this step by step. Let's start by finding the market equilibrium before any hypothetical merger. So we are now looking for the market equilibrium in a world where we have two entities upstream that are in a competition, in a Cournot competition, and where there is one single entity in the downstream market that is acting as a monopolist. All right, so we have these two market levels: competition upstream, monopoly downstream. Let's find the equilibrium for this situation first. And the path forward is the same as it was before. The strategy we are using is the same as it was before. We are, once again, starting with the downstream market, solving the profit maximization problem downstream, and then moving, after we have done that, moving to the upstream market, taking the solution of the downstream market as given. And if we want to do this, well, let's actually apply this strategy. So let's actually start with the downstream market and immediately realize that we actually don't even need to do this, because downstream nothing changed. There is still one, in comparison to task A, nothing changed, because there is still one monopolist in the downstream market. So this function W of Q, the wholesale price as a function of the quantity, is unchanged in comparison to task A. So we can just take this result, write it down, and we're done at this stage. Now, as promised, we take this result into, as given, into consideration when we're moving towards the upstream level of the market. Upstream now, of course, is where the crucial change happened to the model. We no longer have one monopolist. Instead, we now have a Cournot duopoly with two symmetric firms. And we solve this Cournot duopoly basically in the exact same way that we always solve a Cournot duopoly, right? The strategy is exactly the same. We only have to keep in mind that the price that these upstream firms are charging is not the end market price P, but instead the price these firms are charging is W, the wholesale price. Other than that, we are looking at the exact same problem of a Cournot duopoly that we already know and already solved in previous weeks. So, what are we doing? We first start by stating the profit function of both of these firms. And I now, for the rest, will refer to firm I simply because of this symmetry of this scenario, of this upstream competition. So in this upstream market, we have the profits of each individual firm I equal to W minus marginal cost C times the quantity Qi. What we have done here, of course, is we have rewritten this part into minus 2 times Qi plus Qj. Or in other words, in a more general notation, Qi plus Q minus I, so the quantity of all other firms. In this specific case, of course, we only have two firms, so we can name it Qi and Qj. In general, of course, we have this notation Qi plus Q minus I, the quantity of all other firms. All right, now with this profit function, we can proceed just as we usually do when we calculate the market equilibrium in a Cournot. We find the profit maximum by calculating the first order condition of this profit maximum. So we are calculating the partial derivative of the profit function of firm I with respect to the quantity of firm I. If we do so, we then result with the first order condition written down here. Let's call it that, first order condition. We have this, of course, for both firms, symmetric case. So we have two parameters and two equations. We can solve that. We can either substitute one into the other, or however you like to solve it. In previous exercises, we usually stuck to the solution pattern where we were stating the best response functions and then plug them into one another. However you like to solve it, in the end you will find that we have a symmetric equilibrium where both firms individually produce a quantity of 20. So the total quantity in the market, of course, is 2 times 20 equal 40. Then, given this function, this wholesale price as a function of Q, we can calculate the wholesale price for a Q of 40, which yields a wholesale price of 44. And knowing the quantity in the market, of course, using the demand function, we can then calculate the price in equilibrium, which is 84 in this scenario. Alright, so this is the market equilibrium after the merger. We have a quantity of 40. Just as a reminder, under task A we had a quantity of 30. We have a price of 48. Under task A we had a price that was larger, 94. So we see that this introduction of this competition upstream yields a result in which quantity is larger, price is lower, which should be little surprising, right? We introduce additional competition, we reduce market power of the actors in the market, and we see a market equilibrium in which the quantity is larger and the price is lower. Shouldn't be too surprising. All right. Now the next question is, would the merger between PG and TSO be approved? So this is the situation before the merger. Let's have a look at this situation after merger. In the following, simply because otherwise it would be way too messy on this slide, an index of 1 refers to PG, so the firm that is part of the merger, and an index of 2 refers to the firm PG Sun, so the producer that is not part of the merger. Okay, with that out of the way, let's start by stating the profit function of the merged firm. And as usually, the profit function of a merged firm simply can be calculated as the sum of the individual firms that are part of the merger. In this case, the profit function of the merged firm, capital Pi, equal the profits of PG, Pi 1, plus the profits of TSO, the distributor that is acting downstream. In the next line, we simply substitute the individual profit functions which we have already stated in previous slides into this combined profit function capital Pi, so the profit for the merged firm or the firm after merger. And as you can see down here, what we actually have is this part back here would be the profit of wholesale price minus the profit of the producing firm PG. Meanwhile, what we see in the first two summands is the profits of the distributor PG TSO, the profits of the distributor TSO. And just to clarify, this first part of this profit function is the profits of the distributor from purchasing from upstream firm 1 and selling to the market, to the end consumer. This second part of the profit function refers to the profit that yields from selling the good produced by firm 2 to the end consumer. And you can see this because in this case the TSO part of this merged firm, the distributing part of this merged firm, is buying from firm 2 and selling quantity 2, right? Just to decompose this profit function and make it a little more digestible maybe for you. All right. Nonetheless, the important part is that this now is the profit function of the merged firm. All right. Now that we have stated the profit function, we can continue with the profit maximization of this firm. So, this firm then can or maximizes their profits by choosing the sold quantities Q1 and Q2 profit maximizing, right? That's the strategic parameters. So we have this combined profit function capital pi, which is a function of Qi, and we have this combined profit function capital pi, no index, which is a function of Q1 and Q2. So the electricity bought from or produced by producer 1 and the electricity produced by producer 2, as well as the wholesale price for producer 2, for the one producer that is not part of the merger. All right. You will, when you go through this step by step, you will, because the one or other might be asking what happened to W1. Well, if you go through this solution one by one, step by step, you will realize that basically these two terms are just cancelling out. So this wholesale price that would conceptually be just an internal price for the merged firm, because remember, firm 1 PG merges with TSO. So, and W1 of course refers to the wholesale price that TSO pays in order to sell the electricity produced by PG. So this is really referring to the wholesale price that the upstream part of the merged firm would ask from the downstream part of the merged firm. Right? So it makes sense that it cancels out. It's just moving from one pocket to the other. It's neutral to the profit of the merged firm. That's the bottom line. So this all means that in the profit function of the merged firm, W1 does not play a role, but rather the only parameters that still play a role are the quantities Q1 and Q2, as well as the wholesale price that the merged firm would have to pay to PG Sun, the not merged producer, if it wanted to sell electricity from PC Sun to the end consumer. All right. Now for this profit function, we can of course find the profit maximizing strategy. And the firm, this merged firm maximizes profits simply by choosing Q1 and Q2, so the quantity of electricity produced by firm 1 upstream and produced by firm 2 upstream and sold to the end consumer. So the profit maximum then can be found by stating the first order conditions that are written on this slide right here. So we have two first order conditions. We have the derivative of the profit function capital pi with respect to Qi and the derivative of the profit function capital pi with respect to Q2. These two first order conditions then can be used in the next step. Right, there it is. We can use these two, or we can rephrase these two, restate these two first order conditions and find these two entities. First, we know that first we can rephrase this first order condition by solving it for Q1. So we have a function that provides the profit maximizing quantity Q1. So again, 1 is the firm that is part of the merger, of course. The profit maximizing quantity Q1 as a function of the quantity Q2. So this is basically a best response function, right? Furthermore, we can calculate a profit, a wholesale price W2 that that results from this profit maximizing first order condition, right? So we have the wholesale price, the price that this now merged firm would pay to the non-merging producer if it wanted to sell their electricity as a function of the quantities Q1 and Q2. All right. So that's the result from the profit maximization of the merged firm. Of course, if we want to know the market equilibrium, we need to know the profit maximization results for all firms in the market. So let's continue with the profit maximization of the non-merging firm. Now, luckily, the profit function of this non-merging firm is a lot easier than the profit function of the merging firm, simply because we only have one firm upstream, so this is only the profits for one firm upstream. And this firm upstream takes or makes the wholesale price when selling a unit of its good. It of course faces the constant marginal costs that were assumed in the exercise, and this profit margin then of course is earned for any quantity Q2. All right, now that we for the given function for the wholesale price W2, which resulted from the profit maximization of the merged firm. So what we need to understand is that this wholesale price function incorporates the condition that the merged firm's profits are maximized, because that's where this function comes from the profit maximization problem from 1, right? We can use this function and plug it into this profit function to substitute away W2 and instead have a profit function for firm 2 that only depends on the quantity 1 and quantity 2 of the firms. Now, if we want to find the profit maximum of this firm, we of course have to find the best response of this firm, the profit maximizing choice of the quantity of this firm Q2. So we are calculating, mathematically, we are now calculating the partial derivative of the profit function of firm 2, PG Sun, with respect of the quantity of firm 2. So the sold electricity of this firm. We state this first order condition and then we can rephrase it, namely we can solve it for Q2, and then we have this nice function, this nice response function Q2 as a function of Q1. Now what we can realize is we have a best response function Q1 of Q2 that resulted from the profit maximization problem of the merged firm, and we have a function, a best response function Q2 as a function of Q1 that results from the profit maximizing of the non-merged firm, right? So now we have, as we like to have, two best response function, and we can find, based on these best response function, the market equilibrium. Simply, for example, by substituting this function Q2 of Q1 into the first calculated best response, or the other way around, really doesn't matter, because what we're mathematically doing right here is of course finding the intersection between two best response functions. So in this intersection, well then conceptually both firms are of course playing their best response towards the best response of the other players. So where we're at is the market equilibrium. In this market equilibrium, we see that the equilibrium quantity Q1, so the amount of electricity that is produced by PG, that is part of the merger, and then sold to the end consumer, this quantity is 60. At the same time, the quantity Q2, so the quantity that is produced by the non-merging firm PG Sun and then sold to the consumer is 0. All right? So, in this equilibrium, if PG Sun is selling a 0 quantity, that of course implies PG Sun is no longer active in the market. And if we now compare this quantity of 60, this total quantity of 60 with our benchmark situation, under A, where we were in competition, we will realize that the quantity increases. In the benchmark situation, we only had a quantity of 30. Then, in a situation where all of these firms were in a competition, we had a quantity of 40. Now, in the situation where one upstream firm merges with the downstream firm, we are resulting a quantity of 60, which is of course exactly the same that we already saw when we were looking at a perfect vertical integration between one firm each, right? So, in comparison to a situation pre-merger, we see an increased quantity and thereby decreasing prices, which implies that welfare and consumer surplus increase as well. So, through this merger, both welfare and consumer surplus increase, which of course gives us the answer to this question: would the merger between PG and TSO be approved? Well, yes, and it doesn't matter whether we're looking at consumer welfare standard or total welfare standard, because both total welfare as well as consumer surplus are increasing. So, for any of these standards, it would be advisable to approve this merger. Okay, now of course, let's talk about the elephant in the room, which is, well, now one firm, PG Sun, is no longer participating in the market. Okay, and that's exactly what we are going to discuss in task D. In task D, we are asked what type of foreclosure effect is involved here. What type of foreclosure effect is visible here? What aspects must be taken into consideration or into account when assessing this kind of foreclosure effects in accordance with the EU Commission's guidelines on the assessment of non-horizontal mergers, i.e. vertical mergers. Alright, so what kind of foreclosure effect do we see? And this of course is more or less a repetition of the contents of the lecture. Well, in this part we see customer foreclosure. Why do we see customer foreclosure? Well, because for the merged firm, which consists of one of the two producers and the monopolistic distributor, for this merged firm that includes the monopolistic distributor, it is profit maximizing to sell 0 quantity of this second producing firm. It is, in other words, profit maximizing for this distributor to sell only electricity that is produced by the vertically integrated producer, PG. So what we see is that through this profit maximization, the market equilibrium reveals that the second upstream firm, PG Sun, will not find any distributor to sell their product to the customer. And that's exactly why we are talking about customer foreclosure in this scenario. Okay, so what's the type of foreclosure effect involved here is done. Let's then talk about the aspects that must be taken into account when assessing this foreclosure effect in accordance with the EU Commission's guidelines on the assessment of non-horizontal mergers. And in total, we are going to talk about 3 different aspects. The first aspect being the ability to foreclose. And you can find yeah, you can find this content that I will only briefly summarize and go through in the numbers 60 to 67 in these EU Commission's guidelines on the assessment of non-horizontal mergers. So, first to the form. Downstream part of the merged entity covers a larger share of the demand from the upstream part of the merged entity or requires more favorable terms and conditions for its competitors. Of course, what we saw in our model is this first and more extreme version, where the downstream part of the merged entity covers a larger share of its demand, in our case exactly 100% of its demand from the upstream part of the merged entity and 0% of demand from its competitors. So what we need to ask ourselves when we want to assess this is how important is the downstream company as a customer to the upstream companies? And in our case, of course, we assumed that there is only one single monopolist in the downstream market. So this importance of the downstream company as a customer to the upstream market, of course, is as large as possible. In other scenarios where there might be multiple firms downstream, of course, the effects wouldn't be quite as stark as the ones that we saw in this exercise. Second aspect is the incentive to foreclose, and you can find the details on this aspect in the numbers 68 to 71 in the guidelines on the assessment of non-horizontal mergers. And this is basically asking the question, is the foreclosure profitable? Because if it's profitable, well, then we have an incentive to foreclose. And whether or not this is profitable is not always quite as clear as it was in our case, because usually what firms are facing a trade-off, right? This trade-off might be as follows. It might be possible to buy from an upstream part of the merged entity at a lower price versus buying from their competitor in order to rise price upstreams and downstreams. Basically the firms might see different paths towards a profit maximization, and it is not always cut clear the case, as it is in our scenario, that buying only from the vertically integrated part is the path to profit maximization. All right, and then the third and final aspect we need to assess is the impact on the effective competition. And you can read on this aspect in the numbers 72 to 77 in the guidelines on the assessment of non-horizontal mergers. Under this aspect, the guidelines asked to assess the impact on the effective competition in general. All right, and with that we are at the final task E, where we are asked to determine the equilibrium of the situation described in C, where PG and PG Sun are in Bertrand competition. All right, so we are basically reverting back to a situation where these firms are not integrated. Instead, under C, we were looking at a situation where PG and PG Sun, so two upstream firms, were in a Kuno competition. And of course, in a Kuno competition with homogeneous goods, we know that it is quite possible that firms actually make a positive margin and so on, or even expected that firms will make a positive margin on their marginal costs. Instead, what we are now asked to look at is a situation with Bertrand competition. And of course, we are looking at a Bertrand competition with homogeneous goods and identical constant marginal costs. So let's have a look at how this impacts the market results, the market equilibrium. So, of course, we now have, as I described, a situation where upstream there's two firms in a Bertrand price competition with homogeneous goods. So all this competition collapses to the Bertrand paradox, under the Bertrand paradox, so to speak. So what we are expecting is in equilibrium that both firms sell, both Bertrand competing firms sell at a wholesale price that equals marginal costs. So what we are expecting to see is W equals C. And at this point, of course, we could continue and simply plug in this result into the profit maximization downstream and so on and calculate the market equilibrium. However, we can simply skip all this if we realize, when we realize, that this is exactly the same as under vertical integration. So in task B, we already saw a situation where there is one vertically integrated firm which yielded to a situation where this monopolist over both market levels, or which of course implies that we have a monopolist in the conventional way where there is no vertical separation at all, but there's one monopolist facing costs of production and the demand function on the other side. We already saw this situation and we realized that this is equivalent to having a wholesale price that is equal to the marginal costs. So we can argue that this is, or the results that result from this step, from this Bertrand competition on the upstream market, are the same results as in the case of vertical integration, or in other words, this W, or wholesale price, equal to the marginal cost of the firm implies that we have the same situation as if there was one monopolist over both market levels. Now, a different perspective from which we can address this is, remember how we were talking about the problem of double marginalization in the situation where we had a monopolist upstream and a monopolist downstream. Well, now in this scenario where we have on the one market level we have a Bertrand competition, we have zero margin, right? Because wholesale equals marginal costs, zero margin. So we perfectly eliminate one of these marginalizations. So our whole problem with double marginalization is eradicated, and all we're left with is a simple monopolistic market with a single marginalization at the same time.